G'day guys, so today we're going to be looking at how to read a weather map. So we did look at this last week, however I feel it's important we go over this again because it's going to be really useful information and important that you understand this for your upcoming assignment. Alright, so how to read a weather map. First of all, before we continue this PowerPoint, I'd like you to go through and watch the video on the skill builder on the Jack Plus that is called Reading a Weather Map. And that can be found in between chapters 3.1 and 3.2. We did watch that last week, but I'd like you to pause this video now and go and watch that video again, just as a refresher before we go back into the similar content today. Okay, what do we want to take out of today? So we want to be able to identify the following: areas high and low pressure on a weather map, the predicted wind strength by the proximity of the isobars. So proximity, I mean location. So are they close together or are they far apart? The predicted weather, I'm looking at the areas of high pressure and low pressure. So looking at high and low, we can actually tell what the weather might be. If there's any cold fronts or warm fronts coming in, and are there any troughs around? And also areas of precipitation, so areas of rain. How can we identify that on a weather map? Alright, so weather maps use lines and symbols to show areas of low and high pressure and weather events such as warm and cold fronts. The lines are called isobars. We know that. They join places with the same atmospheric pressure. Atmospheric pressure is the weight of the air. So humans cannot accurately feel differences in air weight. Atmospheric pressure varies from place to place, depending on the temperature of the air. Meteorologists use very sensitive instruments called barometers to measure atmospheric pressure. So we can't feel the weight of the air, but it definitely does change. So the average weight of the air is 1013 hectopascals or millibars. Measurements higher than this, such as 1020, indicate areas of high atmospheric pressure, so high pressure, where the air is sinking. Higher pressure, heavy air. Measurements lower than this, such as 985, indicate areas of low pressure, where the air is rising. So lower pressure, light air, it's going to rise up. Now this is taken straight from the textbook, just thought I'd put in there for you to be able to pause and go back and refresh. So you've just watched the video and seen these symbols again and their name and what these do and how these are associated to weather maps, which are very important for you to be able to analyze a weather map accurately. So to use the correct terminology when analyzing a weather map is vital, and that will be assessed on your upcoming assignment. Now I just thought I'd put this in again for you to be able to pause and look at it if you'd like. It just identifies a few of the symbols on this table. Not going to go through them all because I don't want this video to be too long, so you can pause and look at that if you'd like. Now there's 5 steps when looking at analyzing a weather map. We're going to go through those quickly today. Step 1, we're looking for pressure systems, so high and low pressures. So examine high pressure systems, which we know are above 1013 hectopascals, and low pressure systems below 1013 hectopascals or millibars. Pressure systems generally move from west to east as they cross Australia and move around the world. So if looking at this figure 2 down the bottom, we can see that the high from southern Western Australia is moving from the west to the east. And this system is likely to bring fine weather to the region. The low pressure system east of Broome, okay, that's Broome around here. This is the low pressure system we're talking about. Sorry guys. This is Broome here. This is the low pressure we're talking about. So we can see that's 1008 hectopascals. The high pressure coming over this southwestern region or Western Australia is at 1024. So high pressure systems generally bring finer weather. Low pressure systems generally bring air that is rising and creates rain. Okay, step 2, we want to look for air masses and fronts. Examine any air masses and fronts in figure 2. This is figure 2. there is a cold front where cold air meets warmer air. This is likely to cause a fall in temperature and rain in South Australia. So we can see this cold front coming through, which we are able to identify from our table here. So our cold front has got the line with triangles on it. Okay, and we've got this a cold front meeting warmer air, which is likely to cause unstable weather and rain across southern Australia. So when a cold front meets a high pressure system, that is when rain is likely to occur. Step 3, look for precipitation. Examine precipitation patterns, which we know. So precipitation is rain and also includes snow, hail and dew, but as I said is most commonly used to identify rain. In this weather map, over half of Australia has received rain in the last 24 hours. This chart does not indicate how much rain fell. So we can see these diagonal shaded areas of the map that identifies where rain has been in the last 24 hours. Step 4, wind. Wind is not depicted on this weather map. However, the closer together the isobars are, the stronger the winds. So we've learned that as well. There are no significant areas of high wind in Australia on this map. However, if we look closely in the left-hand corner here, we can see that the isobars are actually quite close. Now, despite that's not over Australia, that would be an area of high wind. Where else would be areas of highish wind, do you think? Maybe around here? But over the rest of Australia, it would be actually quite calm. And our last step, sorry guys, is troughs. So the weather map in figure 2 shows a trough in Central Australia, which is identified by this line here. And this trough line runs from central South Australia towards the Gulf of Carpentaria. Troughs are usually associated with unsettled weather and rain. So whenever you see a trough, and identify a trough, that identifies unsettled weather and rain. Hope that helped you today, guys. Please remember to save this video as it will come in handy for your assignment.